Good afternoon, everyone. Welcome to the class. This is Chemistry 1 class for the students of Standard 11. I am Bizli Shaha, lecturer of Square High School and College. Today, I will explain the application of the law of mass action. Last class, we have learned about the law of mass action, and today our topic is the application of this law. Law of mass action, you have remembered. Law of mass action is at a constant temperature at any time the rate of chemical reaction is directly proportional to the active masses of the reactants taking part in the reaction at that time. Active mass is molar concentration or partial pressure. When active mass is expressed as molar concentration, then we will get the equilibrium constant, that is Kc, molar equilibrium constant, and when active mass is expressed as partial pressure, then we will get partial pressure equilibrium constant, that is Kp. Here we will derive the equation for Kc for different reaction. Derivation the equation of Kc. Look, this is a reversible reaction. Here hydrogen and iodine produce hydrogen iodide. This is a reversible reaction. When you will derive the equation of Kc, you have to find out the molar concentration of the reactant and product. Now, this is a homogeneous equilibrium chemical reaction because here the mole number of reactants and the mole number of product is same. Here the mole number of reactants is 2 and product is also 2. So, after finding the equation of Kc for this reaction, you can find out the Kc for every reaction. But here I will show you two reactions and I will give you some homework that you have to do in home. Look, to find out the molar concentration, at first you have to find out the mole number of the reactants and products. Now, when the reaction is started, or at initial when the reaction is not started, at the initial of the reaction, then the mole number of product will be 0 because at the initial no product is produced. Only we will take the mole number of reactant as A mole, X mole, B mole, Y mole or any. Here at initial let the mole number of hydrogen equal A mole and mole number of iodine equal B mole and mole number of hydrogen iodide equal 0 mole. Now it is at initial, but we have to find out the mole number and concentration of reactant and product at equilibrium. Now when the reaction has started and one time it will go to equilibrium, that time the reactants and products all are present at equilibrium. We have to find out the mole number of this reactant and product at equilibrium. It is more easy if we find out the mole number of product at first. Look, here 1 mole hydrogen and 1 mole iodine react to produce 2 mole hydrogen iodide. If we take this hydrogen iodide as 2x mole at equilibrium, let mole number of hydrogen iodide equal 2x mole at equilibrium. Now 1 mole hydrogen and 1 mole iodine react to produce 2 mole hydrogen iodide. Then 2x mole hydrogen iodide is produced from x mole hydrogen and x mole iodine because 2 mole hydrogen iodide is produced from 1 mole hydrogen and 1 mole iodine. So 2x mole hydrogen iodide will be produced from x mole hydrogen and x mole iodine. That means x mole hydrogen is used in this reaction. But at the initial, the mole number of hydrogen was A mole. So at equilibrium, the mole number of hydrogen will be A minus x mole. And also the mole number of iodine equal B minus x mole because x mole iodine is used to produce hydrogen iodide and it was at first B mole. So now it is B minus X mole. We got the mole number of reactants and products at equilibrium. Now to find out the concentration of reactant and product, we need to know the volume of the reactant and product. Let the volume of the gas mixture is V liter. Now at equilibrium, concentration of hydrogen equal A minus X divided by V mole per liter, because mole number divided by volume equal concentration. In this way, concentration of iodine equal B minus X divided by V mole per liter, and concentration of hydrogen iodide equal 2x divided by V mole per liter. Now, what is the equation of Kc? Kc equal hydrogen iodide squared divided by hydrogen into iodine. Concentration of hydrogen iodide is square, because here 2 mole hydrogen iodide is produced and mole number will be the power of this product. Now, if you put the value of hydrogen iodide, hydrogen and iodine in this equation, then you will get the equation of Kc for this reaction. Here, put this value Si, hydrogen and iodine, that is 2x divided by V whole square divided by A minus X divided by V into B minus X divided by V. After simplifying the equation, we get Kc equal 4x square divided by E minus X into B minus X. This is the equation of Kc for the above reaction, hydrogen plus iodine, hydrogen iodide. Okay, in this way we can derive another equation for this reaction. Here the reactant is ammonia. 2 mole ammonia is decomposed to produce 1 mole nitrogen and 3 mole hydrogen. Here also, at the initial, when the reaction is not started, suppose we have taken 2A mole ammonia in the reaction chamber, and at initial the mole number of nitrogen and hydrogen equal 0 mole. Now look, 2 mole ammonia gives 1 mole nitrogen and 3 mole hydrogen. That means from 2 mole ammonia, 1 mole nitrogen and 3 mole hydrogen are obtained. So, if at equilibrium we get x mole nitrogen, then we will get 3 mole hydrogen. At equilibrium, mole number of nitrogen equal x mole and mole number of hydrogen equal 3x mole. Now, x mole nitrogen and 3x mole hydrogen are produced from 2x mole ammonia, isn't it? But at the initial, the ammonia was 2A mole. So, at equilibrium, the mole number of ammonia will be 2A minus 2x mole, because 2x mole ammonia is used to produce nitrogen and hydrogen, and at the initial it was 2A mole. And let the volume of the gas mixture is V liter. Now, at equilibrium, concentration of ammonia equal 2A minus 2x divided by V mole per liter, mole number divided by volume. In the same way, concentration of nitrogen equal x by V mole per liter, and concentration of hydrogen equal 3x by V mole per liter. You got the concentration. Now put the value of this concentration in the equation of Kc. Here Kc equal nitrogen into hydrogen to the power 3, because there are 3 mole hydrogen, divided by ammonia to the power 2. Now when you will put the value of these 3 in this equation, you will get x divided by v into 3x divided by v whole cube divided by 2a minus 2x divided by v whole square. or after simplifying the equation, you will get Kc equal 27 x to the power 4 divided by 4 into a minus xl square into v square. This is the equation of Kc for the above reaction, this reaction. Okay, I hope now the derivation of equation for Kc is easy for you. So I will give you some homework. I will give you to derive the equation of Kc for some more reaction. You will do it in home in your CW copy, and obviously you will submit it in the messenger group. Deduce Kc for the reaction. Deduce Kc for the reaction. First one, N2O4 product 2NO2. Second reaction, PCl3 plus chlorine product PCl5. And number reaction, nitrogen plus 3 hydrogen 2 ammonia. You will do this homework in home, and of course you will submit it in your messenger group. I will give you a fixed time, and that time you will submit this homework. Now students, I want to tell you something. If you follow this class and if you don't show any reaction or any question or any other thing about the class, then how can I understand that you are following my class? So please, after listening the full class, you will, if you have no problem, then okay, you can give a like or any other reaction for this class. And if you have question, obviously you have to ask this. Okay, so thank you everyone, and goodbye everyone.